Hello, I wanted to show you in just one video all the times where you see trigonometric equations over the year 12 and year 13 content. So you learn about trigonometric equations in year 12, in chapter 10, if you are doing Excel, where you learn basic trigonometric equations. Then you see trigonometric equations again in year 13, when in your chapter about radians. So you are going to solve equations with radians. Then you see more equations when you learn about the new trigonometric ratios, so sec, cosec, and cot. And then you learn about the angle addition, the angle addition formulae and the double angle formulae, and you use them to solve equations. Yeah. So I'm going to do a few examples of each, so you know the different options that you have. So first time you see is in chapter 10.4, which is simple trigonometric equations. So the equations are quite simple and really things like this, where you have sine, cos, or tan equal a number, or very, very easy way of finding that sine, cos, tan equal to a number. So for example, if I have this equation here, I'm going to make sine x the subject, just dividing by 5. So I have sine x is going to be minus 2/5. And I'm going to solve this equation in this interval. Please be super careful with the calculator. If you are working in degrees, you have to have your calculator in degrees. If you are working in radians, your calculator must be in radians. Otherwise, your answer will be completely wrong. So calculator in degrees, because I'm working with degrees. You do sine minus 1 of x. The calculator is going to give you the first value, the first answer, the principal answer, which in this case is minus 23.6. First thing you have to do is to check if this first answer is in your interval. And if it's not, find the equivalent. And after that, you're going to find any other solution. So this angle here, minus 23.6, if you have your radius 1 circle, and this is x, this is y, and we are starting to measure angles here, is minus 23.6. So this is the angle. And this is minus 23.6. The equivalent angle in this interval is this big angle here. So this big angle here will be between 0 and 360. So is 360 minus 23.6. So this angle is really 336.4 degrees. I'm doing to 1 decimal place. I think 1 decimal place, three significant figures is a good rounding for angles. So this is your first solution, which really is this one, but written in your interval. And now I have to find other solutions. And to find other solutions between 0 and 360, I'm going to think what other numbers what other angles have the same sign. You can do that with the graphs, with the cast diagram, with the circle. I do it with the circle, but it's up to you how you do the other solutions. So sine, remember, is the vertical line here, is the y coordinate. So I'm looking for another angle in that interval that has the same y with the same sign, which is, yeah, so this is the same sign with the same sign, and I'm talking about this angle here. This angle here is 180 plus 23.6, yeah, so all this angle here, and that angle is 180 plus 23.6, which is 203.6 degrees. And I don't have any other solutions, so the next ones will go over 360 if I just go around and around and around. Yeah, that's why they give me an interval, so I can stop writing answers. So this is the first one. Let me show you other equations that you can have. Same. I have sine of theta is root of 3 cos of theta. In this case, I have to prepare my equation a bit, so I have a trigonometric ratio equal a number. So I'm going to divide everything by cos, and if I divide everything by cos, I have sine divided by cos is tan of theta, and the cos on the right hand side, cos divided by cos is 1, so I have only root of 3. And now I have something that I can put in the calculator, so I do tan minus 1 of theta, and I get my first answer for theta, which is 60 degrees or in the calculator, or if you remember. That's the first answer. That's here. Well, a bit higher, right? So this is my 60 degrees. Remember, the tan is really the gradient of this line. Yeah, so I need one with the same gradient, one other angle. That other angle is going to be this one here. And that angle there is 180 plus 60. So my next answer is going to be 240 degrees. And if I carry on going around, my answers will be greater than 360. So in my interval, those are the answers that I need, no more. Yeah. Then next section in that chapter, you have harder trigonometric equations. So your equation start to look something like this, where you have, instead of x or theta or alpha, you have a number multiplying the angle, or you have, like this one, the number multiplying a constant or coefficient for the angle, or you have the angle plus a number. Yeah. So let me show you both cases. So in the first one, when I have, let's say cos 3 theta is 0.766, I'm going to solve for 3 theta. So I'm going to follow the steps that I did before, but for 3 theta. The first thing you have to do in these questions is, if you are solving for 3 theta, you have to write your interval for 3 theta. So your new interval is going to be the same, but multiplied by 3. So 0, 3 theta, 1080, yeah? So this is your new interval. So we need to find the solutions, all the solutions in this interval, not in this one. So can you see that the number is much larger? If you solve in this interval, you will be missing solutions. Yeah, so you have to use this interval. So what I'm going to do is cos minus 1 of this in the calculator to find the first solution for 3 theta. So my first solution for 3 theta is 40 degrees. 40 degrees is here. And I need another angle that has the same cos. Cos is the x component, yeah, this one. So I need another angle, which will be the symmetrical in the x-axis. So is this angle here, all this angle here, which is really 360 minus 40, yeah, which is 300 and, no, minus 40. Yeah, 320, sorry, 320. So this is my main answer with the calculator, and this is the equivalent one. So what I'm going to do now is adding 360 and go around. So this angle here is 360 plus 40, which is 400. Then I can carry on because I am under 1080, and this one is going to be 320 plus 360, which is 760. No, 600. What I'm doing? 680. Yeah. So this one is the same, adding 360. This one is the same, adding 360, and then I carry on until I reach the 1080. Yeah, just adding that. So 760. And 1040, and the next one will be over 1080. So these are all my solutions for 3 theta. I'm just going around and around and around until I reach my limit for the interval. And the last thing you have to do is divide by 3 to have theta. So I'm going to divide these numbers by 3. So it's going to be 13, it looks like minus, sorry, 13.3 degrees, 107 degrees, 133 degrees, 227 degrees, 253 degrees, and 347 degrees. Yeah. So these are the options. And the important thing with these questions, when you have 3 theta or 2 theta or a half of theta, is that you transform your interval and find all the solutions in your interval. If not, if you use this interval, look how many solutions you are missing. Yeah. The same when you are adding or subtracting an angle. When you are adding or subtracting an angle, you are going to transform the interval first. yeah? So you are doing sine x plus 60, 0.3. So you are adding 60 to your interval. So your new interval is going to be between 60 x plus 60, because you are looking for solutions for x plus 60 really, and 360 plus 60 is 420. You go to a calculator, do sine minus 1 on 0.3, and the first solution for x plus 60 is 17.45 degrees, which is here, yeah, so 17.45 degrees. Always check that the answer in the calculator is in your interval. In this case, it's not in my interval, so I'm not going to mention it at the end, yeah? This is not in the interval, it's smaller than 60. So I'm going to find the equivalent here. So this, no, what I'm looking for the sine, sorry. Sine, I'm looking for the y. So my angle, my first angle that gives me a solution is this one, which is 180 minus 17.45. So my first answer that works is going to be 162.4554. So this one is not valid. And then I just go around until I reach 420. So the next one will be 360 plus 17.45, which is 377.45. And the next one will be one whole term and this one, and it's over 420. So I have only two solutions, but remember, this one is not one solution. These are my solutions for x plus 60. So what I'm doing is take away 60 to get the solutions for x. So solutions for x are going to be 102 point, I'm going to run to one decimal place again, and 317.5. And those are my answers, yeah? So again, transform the interval first, find the solutions in the interval, all the solutions in the interval, and at the end, you take away the 60, yeah? Now, second year, you see equations in radians. They are going to look like the ones that we did before, so not too complicated, yeah? But my intervals now are going to have pi's. So instead of say, like here, 360 degrees or 180 degrees, it's going to be clear that you are working in radians because it says something pi. Pi halves, minus pi, pi, 2 pi, something like that. Yeah, even if they don't say it's radians. We are working exactly the same, but with the calculator in radians. Don't forget that. And I'm going to show you one that is a bit particular. You can find it in degrees as well. Where you have a square. So we have sine square here and we have cos. So a mix of cos and sine in the same equation. So what we are going to do is to use the identities to substitute one, the cos by the sine or the sine by the cos, wherever is more convenient for the equation in particular. In this case, I have cos and sine square. So I can say that sine square, I know that sine square is 1 minus cos square. So I'm going to substitute that by 1 minus cos square. So I have all my equation in cos. So that will look like 17 cos theta plus 3, I'm already expanding the bracket, minus 3 cos square of theta is 13. So I can rearrange my equation and I have 17 cos theta plus 3 sine plus 3 cos, sorry. No, let me completely reorganize. So I have 3 cos of theta, 3 cos square of theta minus 17 cos theta, and then minus 13, 10, right? I'm done incorrect. 3 minus 17 and minus 10 will be plus 10. Okay, and then you have something and something square. Every time you have something and something square is going to be a quadratic. A quadratic in that something. So it doesn't matter if the something is x, is e to the power of x, or is cos, like in this case. So this is like having 3x squared minus 17x plus 10. So I'm going to factorize like I would factorize a normal quadratic. And I have 3 cos theta minus 2 cos theta minus 5 is 0. Yeah, I'm just factorizing like a normal quadratic. And then I can make this factor equal to 0 and this factor equal to 0. So these equations, when I have squares, will potentially give me more solutions. So, and I have to explore both options. So if I make the first bracket equal to 0, I get cos theta is 2/3. If I make the second bracket equal to 0, is cos theta is 5. And I have to check both solutions and find the answers. So the first one, I do cos minus 1 with a calculator of 2/3, and my first solution is going to be in radians, this one. Yeah. If I work in radians, remember I have 0, this is pi halves, this is pi, and this is 3 pi halves, and this is 2 pi, or 0. Yeah. This angle here is smaller than pi halves. Pi halves is something like 1.6 or something like that. So my angle is going to be below that. And I'm looking for the cos. So I'm looking for the horizontal. So my next solution is going to be one that has the same cos. And that one, so this solution here, this angle is going to be 2 pi minus 0.841 radians. Yeah, you do that with the calculator, and then you find the second solution that would be 5.44 radians. And you don't have more because the next one will be over 2 pi. Yeah. And now I explore this solution. Be careful because cos of theta, remember that cos of an angle is between -1 and 1, so it cannot be 5. This one is not possible. And even if you don't realize, when you do cos -1 in the calculator, it's going to give you an error. So that's fine. So my two solutions in that interval are these two solutions. So this is how I work with radians. Exactly the same, but just the calculator must be in radians, and you have to have an idea of what the angles are. So this angle, pi halves, is like 1.6 radians. This one is going to be 3.14, which is pi, and this one is going to be 4.7, I think, and this one is 6 something. But it's the same. Then you see again trigonometric equations when you introduce the new trigonometric ratios. So sec, cosec, and cot. And you have equations with them. So sec is a number, cot is a number, or a mix of them. Remember, you learned some trigonometric identities with these trigonometric ratios. You have to remember them. So I'm going to show you again some examples. So you have to solve sec of theta is -2.5. This is the interval. If I have to find sec of theta, or sec -1, that's not in the calculator. So what I have to do is to change into something that is in the calculator. I know that sec theta is the reciprocal of the cos. So this is 1 cos. And this is -2.5, which means that cos theta is -0.4, so 1 over 2.5, and this is in the calculator. So now I can do cos -1 of -0.4. If you do that, you get the first theta, which is 113.6 in degrees, is in my interval. So this is my first answer, which is somewhere greater than 90, so somewhere here. And another solution, I'm talking about cos. Cos is here. So another angle that gives me the same cos is this one here, which is 360 minus 113.6. These to one decimal place. Yeah, and I don't have more solutions below 360. I will need to just go around and around. So this is the same. It's just you don't have this in the calculator. You have to write with something that you have in the calculator. Another one, in this one, you have a mix of something square and something not square. So we need to substitute one in terms of the other. Remember, we have one identity with cosec and cot. That is this one. So I'm going to use that one because that way I have cot square here and cot here, and I will have a quadratic equation and it will be fine. So I'm going to multiply already the brackets. So 4 plus 4 cot square theta minus 9 is cot theta. And I'm going to have a quadratic. So if I reorganize this, I have 4 cot square of theta minus cot theta minus 5, right? Yeah, I can factorize like any quadratic. So I have 4 cot, 4 cot theta minus 5 cot theta plus 1, and I make the first bracket equal 0, so I have this, and the second bracket equal 0, this is 0. Second bracket equal 0 is cot minus 1. Again, I don't have cot in the calculator, but I have tan, which is the reciprocal. So tan of theta is going to be the reciprocal, 4 over 5. Find theta with the calculator, doing tan minus 1. You get 38.7 degrees, which is in your interval, and it's an angle here. Another solution is going to be same gradient. So same gradient is 180 plus 38.7. So my next solution is going to be 219 degrees. And then I explore this one. Cot is not in the calculator, so I do tan is the reciprocal minus 1. So that means that theta is going to be 135. That one, let me clean this. That angle, 135, is here. And I need the same tan. Same tan is this angle. And this angle here is going to be this whole thing. Yeah? Which is 180 plus 135. And that is 315. So your answers, if you want to write them in order at the end, would look better. So theta will be 38.7 degrees, 135 degrees, 219 degrees, and 315 degrees. Are all these? Yeah, 4 answers. So this is how we work with cot and sec and cot and cosec. We have to write in something that we know how to put in the calculator. So we work with the equations and normal, and when we get something like this, we rewrite the expression in a way that we can use the calculator. Next thing you see is the double angle formula or the addition formula. So we have equations like this one, like this one, like this one. You will be thinking, but we have done questions where I have theta minus 60. So we did one here. Let me show you at the very beginning, like this one. Sine of x plus 60. And we didn't need the addition formula. It's because in these equations, you had only a trigonometric ratio of that thing. Yeah, so like sine of x plus 60, done. But here I have a mix. So if you see these questions, you have cos of theta plus 30, but then you have sine of theta. So you have two different angles. Or here you have cos of 2x and cos of x. Tan of 2y, tan of y. So in the same equation, you have like an addition angle and a normal angle, or a double angle and a normal angle. That's why you cannot do what you did before. So one of them has to change into the other. The same that when I have sine and cos in the same equation, one of them has to go. So what I'm going to use is the formula, the addition formula. The addition formula are in your formula booklet. So let me show you. Sorry. in A-level maths in trigonometric identities. So you have the addition formulae here for sine, for cos, and for tan. And you don't have the double angle formula, but are very easy to deduce from these ones. Yeah, so don't worry because you have them in the exam. So what I'm going to do, let me show you with one example. I have to solve this one, and I have sine of theta and cos of theta minus 30. I'm going to change this cos of theta minus 30 using the addition angle formula. I have them here, and so I'm going to use the addition for the cos. So what I have is, instead of cos of theta minus 30, I'm going to write the 4 at the front, and then I'm going to do cos of theta, cos of 30, plus, remember when I have minus, this is a plus, sine of theta, sine 30. And I'm going to first organize this expression and then substitute in the whole equation. Actually, I'm not going to even to multiply by 4 yet. Yeah. So this is just this bit here. Cos of 30 is root of 3 divided by 2. Sine of 30 is 1/2. So this expression here really is root of 3 divided by 2 cos theta plus 1/2 sine theta. And now I'm going to substitute in my equation. So I have 4 multiplying this thing. So I'm going to cancel, I'm going to divide by 2. So I have 2 root 3 cos theta plus 2 sine theta equals, so I'm here 8 root 2 sine theta. Yeah, I'm going to put the sine together, and I have 2 root 3 cos theta is 8 root 2 minus 2. I cannot do more than that, sine theta. And I have sine and cos, so what I'm going to do is to divide by cos to have tan. So if I divide everything by cos, I have 2 root 3 is 8 root 2 minus 2 tan theta. Therefore, tan theta is 2 root 3 divided by 8 root 2 minus 2. And now I can use the calculator because this is just a number. Yeah. So I do tan minus 1 with the calculator, and I get my first value, my principal value. So theta is going to be 20.4 degrees. 20.4 degrees, which is somewhere here. I have to find tan, so the same gradient. So the next answer is going to be 180 plus 20.4, which is 204. And the next answer, so 200.4, sorry. The next answer will be over my limit for the interval, so I don't have any more answers. Yeah, but that's how we do, how we use the addition or the double angle formulae when we have in the same equation an angle with addition and an angle without. Yeah, we would need to do the same every time. And the last time to see the trigonometric equations is when you learn to simplify a cos b sine. Yeah. So many of the questions will ask you first to express this in this form, and then solve the equation. But the equation initially, if they don't tell you this, that it could be, you will have something in cos and sine that you cannot divide, because if you divide here by cos, you will have 1 tan, and then you will have 3 divided by cos. So again, you cannot do anything with it. So our equations where I have another thing here and divided by cos doesn't help. So we are going to transform this expression into one that has only cos or only sine. Yeah, more. So again, given that this can be written this way, solve this equation. Yeah, so they are asking you in most of the questions to write first the expression and then solve. But if they don't tell you, they don't tell you first to write the expression, still you have to do it to solve this equation. So let me show you. I have to first write the expression. So let me show you how we do these questions. I have 2 cos theta plus 5 sine theta has to be written in this way. So what I'm going to do is to write the addition formula for cos of theta. And so I have 2 cos theta plus 5 sine theta is r, and I'm going to write cos theta cos alpha plus sine theta, just using the addition formula, sine theta sine alpha. And I multiply the brackets, so I have 2 cos theta plus 5 sine theta is r cos theta cos alpha plus r sine theta sine alpha. Alpha and r are just numbers, are constant. So that means this is going to be a constant. This is a variable. So theta changed, but not alpha. So this means, I'm going to stop because of the noise. I don't know if you can hear it. So really r cos of theta is just a number, a coefficient. And if you compare both sides of the equation, the coefficient that multiply cos of theta is going to be 2. So I can write an equation, this one is the same. I can write that 2 is going to be r cos of alpha. And if you compare the coefficient of sine in the same way, you have that this one is the same, yeah? So I write another equation that says that 5 is r sine of theta, sine alpha, sorry. So simultaneous equations, two unknowns, r and alpha, and that's what I need to write my expression in this way. To solve them, what we are going to do always is divide the one with the sine by the one with the cos. So if this is 1 and this is 2, we are going to divide by 1 by 2, and we get 5 halves. The r is cancelled, is tan alpha. You solve that equation, and then you find alpha is, just doing tan minus 1, is 68.2 degrees. And it says that alpha must be between 0 and 90, so there are not other solutions. The next one is over 90. And then to find r, you could substitute alpha here and find sine, and then do r is 5 divided by sine, but sometimes you don't get the exact answer and they ask you the exact answer. So it's just better. You will see that some exam questions, they say find the exact value of r. The best way is to use sine alpha square plus cos alpha square is 1. Use my identity and write that cos alpha is 2 divided by r. So 2 divided by r squared, and sine alpha is 5 divided by r. So 5 divided by r squared is going to be 1. And from here, you find r in an exact way in case you need. So this is 25 divided by r squared plus 4 divided by r squared is 1. So you have 29 is going to be r squared, so r is root of 29. It could be plus or minus, but here they say r is positive, so we are going to pick the positive value. Yeah, that means that this expression here, yeah, can be written as r cos of theta minus alpha. So really can write r cos of theta minus alpha. That was 68.2 degrees. Yeah, so my expression is really this one. And now when I have to solve this equation, instead of using this, and it say hence, every time they say hence, please use what they say, what you have found in the question before. You are going to use this expression equal to 3. Because, sorry, this is not with the equal, it's just root of 29. Because that's easy to solve. I just have cos of something. So to solve this equation, let me remove this. To solve this equation, we have that cos of theta minus 68.2 is 3 over 29. And now I have an equation like the ones that I have in year 12. So I have a difference of 2 angles, but only one cos of that. So what I'm going to do is to transform my interval. My interval was between 0 and 360. So now my interval is going to be that minus 68.8. So my interval is 68.2, sorry. Theta minus 68.2, smaller than 360 minus that is 291.8. This is my interval. I do this with the calculator and I find theta minus 68.2. The answer for this one is 56.1 degrees and minus 56.1 degrees. But my angle, no, yeah, this is in my interval. So the ones that are in my interval are these two solutions. And when I do theta, so I add the 68.2 to find theta. My first solution is, if I get this as a first solution because it's smaller, it's going to be 12.1 degrees. And this one plus 68.2 is 124.3 degrees. Yeah, and this is how I solve these equations, where I have sine and cos and something else that doesn't allow me to use the tan. I'm going to write this expression this way. If they tell me in one previous question to get some marks, perfect. If not, you still have to do it. Yeah. And this is how we do it. So this is all the main type of trigonometric equations that you find in year 12 and in year 13.